and welcome to the class of Basic Electrical Engineering. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Engineering College, Electrical Engineering Department. So today we will discuss on an introduction to DC circuit, the basic electrical engineering. So the DC, that is stand for direct current, that is known to us. How a DC is formed. Today we will start with how a DC is formed. Let us take this one is a battery. This is the positive half of the battery, this is the negative half of the battery. And positive half connected to a load. So this is the bulb. A circuit is complete in that particular way. A bulb that is connected to a battery. Now we will concentrate on how DC is formed. In order to find how DC is formed, the direct current is formed. So first of all, we will consider that what is current. Current is generally a flow of electrons. Our general convention is that the direction of the current flow is opposite to the direction of the electron flows. The direction of the current flow is the opposite to the direction of the electron flows. That is our conventional method. So let us, if consider that if the direction of those electrons are uniform, then we will obtain a steady flow that is called a DC flow. So when this battery, this is the positive part of the battery and this is the negative part of the battery. When a battery is turned on, this will allow an electron to flow like that. It will allow an electron to flow like that. In that way, the electron is flowing. In a particular way, the electron is flowing. Means there is a generation of current. And you see that the flow of the electron is unidirectional. It's coming out from the positive part through a conductor. It is coming out to the positive part and it is coming back to the negative part of the conductor to complete a circle or a complete cycle. And the circle is completed means complete loop is there that will allow a current to generate. It's called the voltage bulb. Allow a current to generate the flow of electrons or the charges. When this electron passes through that particular bulb, it Means the current is flowing through the bulb means it is glowing. The bulb is glowing. So from there it is obtained that current is when a voltage is applied is generally known to us. It is the rate of change. It is the rate of change the charges that is known as Q. So I equal to dq by dt. So if I saw the flow of the electrons, it is a unidirectional flow. So means the voltage that is generated in with respect to time, the voltage that is generated with respect to time has a steady behavior. Has a steady behavior. This is generally known as direct one, direct voltage, or say the voltage or current, anything, output generally known as. So this is called the DC one, direct current. Generation is a output, there is a current that we obtain is a direct one. So this is the general formation of DC. DC or the direct one is a uniform output that we obtain with respect to time and steady value and it's a unidirectional value. There is no change in the direction. So this is generally known as the DC. So we have know how a DC is formed. So this is the general formation of DC. So let us take another question about the Ohm's law. About the Ohm's law. We all know about the Ohm's law. Let us memorize it. The Ohm's law states that current that is flowing through a conductor between the 2 points is directly proportional to the voltage across the 2 points, keeping all the parameters, other parameters are constant. So the Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points. Let us take a 2 point. One point, this one, this is called the A point, and another point is this one, this is called the B point. So, according to the, and let's take the potential at that point is VA, and potential at that point is CB. So, according to the Ohm's law, current that will flow, say the current that is I flowing through the conductor or passing through the conductor is directly proportional to the voltage difference. Means mathematical expression. The voltage, this voltage is called the higher potential, and this is called the lower potential. And currents always flowing from the higher potential. The tendency of the currents to flow from the lower potential. The voltage difference between there's 2 points that A and B. The 2 points, the voltage difference is VA minus VB. So this one is taken as equal to V. It's directly proportional to the current. So if I omit the keeping all the other parameters constant, proportionality constant, omit the proportionality constant. So proportionality constant R is there. So R is known as the resistance of the conductor is V by I. So this is the conception of resistance is come into the play. So R is V by I. When a potential difference is there, it will allow a voltage to flow. When a potential difference is there between the 2 points, it will allow a current to flow through the conductor, and the voltage difference is directly proportional to the current, or the current that is flowing is directly proportional to the voltage. Be proportional to I, that is the voltage difference is directly proportional to the current, and if we omit the proportionality constant, we are getting a proportionality constant called R. It is known as resistance. So R equal to V by I. This is the Ohm's law that is known to us. Let us concentrate on the R, L, and C. R is generally known as resistance. And now we will concentrate on L and C. L is the inductor and C is the capacitor. And then we go for the units of R, L, and C. So let us, there is a basic conception of the R, how R is comes into the play here. System we generally tendency to oppose the flow of the current. This is known as resistance. Now I am coming to the conception of inductance or the inductor. Inductors are like that formation, and it is denoted by L, and it is when a current is flowing through an inductor, it is act as a coil, and when a current is flowing through a coil, there is a generation of the flux is there, and that flux, the generation of the flux is directly proportional to the current flowing through the inductor coil. It is act as a coil, and these are the turns. So if I omit the proportionality constant, we are getting proportionality constant L, that is known as inductor or inductance, and L is, that is pi by I. This is the equation of the L, the conception of inductor or inductance. It means it is generally responsible for producing the flux, and this flux is directly proportional to the current that flowing through the inductor. And if I omit the proportionality constant, we are getting a proportionality constant called L, which is known as inductor. L equal to phi by I. So this is the conception of inductor. Now I am going to the conception of capacitor. So the conception of capacitor is generally known to us. The two plates that are connected parallel, having a dielectric medium between them, and the general responsibility of the capacitor is to accumulate the charges. If one plate is accumulated with a positive charge, the same amount of charges is accumulated by the another plate. So it will create a potential difference between the two plates, say the V. So it's proposed that the potential difference that is created is directly proportional to the charge that is accumulated by the by two parallel plates. So we can write that the charge is accumulated in the consumption of capacitor is directly proportional to the capacitor. Charge that is accumulated by the two parallel plates, it is directly proportional to the voltage that is generated between the or the voltage difference between the two parallel plates. So if I omit the proportionality constant, we will get a proportionality constant called C. So this proportionality constant is known as capacitor, and it is given by Q by V. So this is the general equation to formation of the capacitor. Two parallel plates, that the two plates are connected in parallel and they are responsible to produce same amount of charge, that is the plus q and the minus q, and those charge that is generated within those two or accumulated within those two parallel plates are directly proportional to the voltage difference between the plates, that is q proportional to v. And if I omit the proportionality constant, we are getting a capacity, proportionality constant called C, that is known as capacity, and C equal to Q by V. Now let us take the units. Say, current is generally known represented by I, and it is denoted by ampere, A or amps, AMPS, current. Voltage is generally denoted by V, and its units are volts. Now the resistance R, denoted by R, the resistance, and according to the name of George Ohm, according to the name of George Ohm, the unit is of resistance is ohms, or it will be denoted like that, ohm, according to the name of George Ohm. So capacitor is symbol is C, and according to the name of Michael Faraday, according to the name of Michael Faraday, the is denoted, the unit is farads. The unit is farads according to the name of Michael Faraday. And the inductor, the symbol is L, and the unit is according to the name of Joseph Henry. According to the name of Joseph Henry, it is denoted by Henry's. It is denoted by Henry's. Symbol in Q is H. So these are the symbolic view of current, voltage, resistance, capacitance, capacitor, and inductor, or capacitance or inductance, and the corresponding units are ampere or the amps for the current. For the voltage, it is volt. For the resistance, it is ohms. For the capacitor, it is farads, and for the inductor, it is henries. So let us take a circuit. That what we have learned now, we are taking a circuit having a 10 volt of this voltage, and resistance is 5 ohm. So my question is that the what is the value of current flowing through the circuit I. What is the value of I? We have to find the value of I. So in order to find the value of I, we all know that V equal to IR from the Ohm's law. From the Ohm's law, this is known to us that V equal to IR, the mathematical representation of the Ohm's law. So we can easily find that I equal to V by R, that is 10 by 5 equal to 2 ampere. Now, the question is that if there is a voltage, then there will be current. If there is a voltage, then there will be current. The answer is no. If there is a voltage difference, then there is a current. But I have not shown any voltage difference. I just written 10 by 5. I have not shown the voltage difference between the 2 points. So why that the conception of voltage difference is there, but still I am telling that there is a voltage difference and the current is flowing according to the Ohm. So let us take this equation: 10 minus 0 by 5. Now from where this 0 value, now it is showing a voltage difference, 10 minus 0 by 5. So from where this 0 value that I have get, which potential, of that, from where this 0 voltage or the potential of which part is 0 voltage, just come to that point. This point having a potential of 0 voltage. So this is 0, this is plus 10. So the potential difference is 10 minus 0 is 0. So why this is called the zero potential? This zero potential means it is called the ground, potential, the ground. And from that conception of the ground, ground, the potential of the ground is zero. Now from that conception, the voltage difference is came into the play. So now we can write the current is 2 ampere. Means we have created a voltage difference that is K minus 0, and the 0 is generally known as the potential of the negative side of the battery, or in other words it is called the ground potential. So according to the Ohm's law, if there is a potential difference, it will allow a current to flow. The value of the current is 2 ampere. Now let us discuss about some characteristics of the network elements. One is called the linear and the non-linear elements. A linear element shows the linear characteristics of voltage versus current. Thus, the parameter of a linear elements remain constant. That is, the parameter do not change with voltage or current applied to that element. Resistors, inductors, and the capacitors are linear elements. On the other hand, for a nonlinear element, the current passing through it does not change linearly with the linear change in applied voltage across it at a particular temperature and the frequency. In a nonlinear element, the parameters change with applied voltage and current changes. Semiconductor devices like diodes, transistors, thyristors, etc. are typical examples of nonlinear elements. Ohm's law is not valid for the nonlinear elements. So this is the basic conception of linear and the nonlinear elements. Now the active and the passive elements, that is the if a circuit elements has the capability of enhancing the energy level of an electric signal passing through it, it is called the active element. That is a battery, a transformer, semiconductor device, etc., which has the capability of enhancing the energy level. Otherwise, the element that simply allows the passes the signal through it without enhance is called the passive element. That is resistors, inductor, thermistors, and the capacitors. Passive elements do not have any instinct property of boosting an electrical signal. So the active elements has the property to boosting the electrical signal. So we know transformers are generally used to step up or step down the voltage along the with the battery also. But in case so that is why they are called the active elements. But in case of the resistors, inductors, capacitors, they are only allowed to pass the electrical quantity. So they have not any boosting property. So that is why they are called the passive elements. And in the other hands, transformer semiconductor devices are known as active elements. So another part is unilateral and bilateral elements. If the magnitude of the current passing through the element is affected due to the change in polarity of the applied voltage, the element is called unilateral element. On the other hand, if the current magnitude remains same even the polarity of the applied voltage is reversed, it is called the bilateral element. Unilateral elements often varying impedances with the variation of the magnitude or direction of flow of the current, while the bilateral elements offer same impedance irrespective of the magnitude or direction of the flow of current. The resistors and inductor and the capacitors all are bilateral elements, while diode, transistor, etc. are the unilateral elements. Means when a magnitude of the current passing through the element is affected due to the change of the polarity of the applied voltage, it is generally known as unilateral element. But in case of the bilateral element, if the polarity of the applied voltage of the is reversed, the current magnitude will remain the same. And the resistors, inductors, and the capacitors are all the bilateral elements, while the diode transistors are the unilateral element. So today we will learn about the formation of DC, the different elements, that is the resistor, capacitors, inductors, why they are formed, and what is the mathematical relation with them, and along with their units, along with the conception of the Ohm's law, and we will obtain example in order to find the application of the Ohm's law, and along with the linear network, nonlinear network, unilateral network, bilateral network, active and the passive elements have also we have seen today. So the when we form the formation of the DC is generally a steady or a unidirectional output that we obtain from a DC output. Means the direct current is a unidirectional. There is no change in the direction. Thank you.